Hello guys, and welcome to another exciting episode of Zyclones, how to build your own drone. And I know when I was starting out, I wished somebody would have showed me the programming aspect, especially because a lot of people don't understand that in order to build a precision aircraft, you have to do precise controls. And one of the most mind-boggling thing is, what does all this mean? So in this episode, I'm going to show you how to adjust your servos and the radios by fine-tuning the program, and show you specifically what these things mean so that you will understand and know. Alright, so I guess the best thing to do is start with the channel reverse. You got those 5 spots. You see everything is 5. Channel 1, channel 2, channel 3, channel 4, channel 5, and channel 6. Of course, if you come here to your helicopter, this is channel 1 over here. That's the aileron, meaning an airplane, the things that make the wing. Alright, and then channel number 2 is the elevator back here. This pushes it. Okay, let me plug in the craft. Sorry guys, again, I forgot to plug the damn craft in. So we got precise control as we adjust it on the computer. Sorry for the darkness there, but that's the elevator, the back one. The back servo there. I put up these little things to assist me in my little thing. There's the elevator, the aileron. And the aileron is also this, but I'm trying not to disturb my homemade fly bar lock, because that's how we'll be adjusting the pitch. And this would be the long axis pitch. And basically that's what I'm going to be showing you with that arrow, is how this moves in relation to the AFR and all these settings. Most of you are concerned with AFR, and I'm going to tell you guys that 60%, you can set these to 100 or anything, but watch if I set, say, channel 2, I think would give me the problem, the elevator there. If I set the AFR on this is just 60%, meaning that you're not giving it 100% range of motion on the servo. So let's set that at 100 and see exactly what will happen. You can set these at negative 100 or positive 100. And I'll explain all that as we go, but right now you want to go up here and send settings to the radio. You'll automatically hear it there on your bird crank up. Now listen, we got 100% on channel 2 back here. What's going to happen if we give it full? Maybe you can hear it there, that at the top the motor's still going, so that'll strip your motor out. So we don't want 100% there. We want 60, and that's where you're dialing in. But basically, I'll show you if you want 100%, what 100% actually does. We'll do this on channel 6 here. We'll make that 0% on channel 6 and see what happens. There's 0% on channel 6. Send the settings to the radio. Now what happens when I do aileron? This is supposed to move. But very slightly compared to what it can move. And basically there, by these percentages on the AFR, if you're a novice beginner, you could set this at 40%, meaning that the stick movement here, as you do it, will only transfer 40% to the swash plate. If you transfer 100%, then the swash plate will give you 100%, which you might not be capable of handling at your stage of experience. So if you could actually diminish that swash plate, like right now, how it moves by adjusting 60% over 100%. 100% would tilt this back even more, and that's why you hear the servo motor back there all groaning like that and everything. To adjust for that, you'll actually have to adjust the linkages and everything so that you can get that type of servo pitch without bottoming out your motor. But you've got channel 1, channel 2, and channel 6. So that's aileron, that's elevator, and that's the channel 6 is the other side of the aileron. Notice you don't have channel 4, which is the rudder. That's the gyro's job and all that back there. Dual rate, we won't get into dual rate at this point. Just stick with these adjustments that you see here. You can put 100% on, 100% off and all that. But endpoints are another important thing. I think you pretty much understand what this does. Channel 6, I guess. Look, you see how it says R? That means it's reversed. So, if on channel 6 here, say when you're doing your left aileron, and it goes up instead of down, because if you're going left, that side's supposed to come up, and that's supposed to go down. So, if that thing is going up instead of down, what you'll do is just simply go in here and click on that and change it to normal. And now you see that it goes up instead of down when I go left. They go together, which is how it would look. So you switch one or the other, but one of them has to be switched, so you'll reverse it. There you're reversing the motors. The end point. Okay, you notice I've got channel 4 with 40 and 70. That's because when I get back here and do that, this is the motor fork. Well, if I had this on 100%, it would basically bottom out. The pitch, meaning the motor would still try to push when this has reached the end of the stroke. So, you can see right there, I've adjusted my end points so that on one extreme it's 40, the other extreme it's 70. You can make negative values and everything, so if it's needing to go the other way, you just put minus 40. But right now, all the servos seem to work, which is the best, is 100% range of motion. All the servos seem to work with the 100 except the rudder, which I'd had to shorten. But if I had a larger shaft, a wider shaft, of course I could let it go. You can adjust these by adjusting the length of the fulcrum, say, or many little things that could adjust mechanically, but it's very simple just to come in here in the radio and decrease the value of that. Throttle percent, you have normal and idle curve. Let me explain the 0.1, 0.2, 0.3, 0.4, and 0.5 and what that relates to and all this. Here is your throttle and there is your pitch. And what happens is when you push this left stick, it's throttle and pitch, meaning pitch is this. I've got to adjust my fly bar lock again. And you see it's a cheap 5-bar lock because I haven't got my lock yet. But we'll put this at dead center of the camera. I'm going to go for 0 pitch. I'm not dialing the pitch in yet and everything. I'm going to wait till I get a fly bar that goes in that hole, because obviously what I got for some reason doesn't fit. But here we go. There's the pitch. And what it is here's 0.1. That's 0, but I've got negative on that. We'll adjust all that, plus the fly bar can be off right now, but I'm just demonstrating now. As I raise the stick, the craft gets pitched, and that's how it takes off. So you'll adjust this curve here. So 0.1, 0.2, 0.3, 0.4, 0.5. It's like this, and this is how it relates to your stick. 0.1 is down here at the extreme bottom. I guess you could see this thing. Maybe I need to put the lights on. The freaking remote. Oh, come on. The radio. Anyways, you can't even see the stick there. Well, anyways, if that were the control stick, 0.1 is here at the bottom, 0.2 is here, there's the middle, 0.3, 0.4, and 0.5. So at 0.1, at this spot, that's what 0.1 relates to over here. And that's where you're dialing the pitch, the amount of pitch at 0.1. Then 0.2 is you move the stick up half of half, okay? 0.2, it'll be 60%. Or that's the throttle, sorry. My pitch is 0.1, 40% pitch to 0.2, 40%, 0.3, 50%, 0.4, 75%, 0.5, 100%. Of course, don't pay attention to my idle mode there, because I haven't even set that up, because in idle mode, I want the half point to be 0 pitch, and then this positive 100, positive 100, minus 100, minus 75, and 75 positive on top. Because, you know, you want negative pitch, and it'll be 0 pitch at the center, but my damn battery's about to be out. But that's what the points there correspond to. So as you move the stick on your remote, the throttle and everything will be given whatever you programmed at that point. You know, if you program 10% throttle there, and 0.2, 100%, 0.3, 50%, 0.4, 60%, 0.5, 10%. It would reflect that as you push the throttle stick up. It'll be 10%, 100%, whatever. As you went down the line, the motor would be going zzz, 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 as you programmed it. So you're programming the throttle here, and then the pitch there, and that's the same thing. That at the 5 different points, reading that this is 3 at dead center stick. You know, 1, 2, the 2. 3 is dead center, and then 4, you just consider that 2 and the 4 half of the half on the line. So that's basically what it is. The center of the stick is 0, and then going above it is positive, pulling down is negative. Going to the left is negative, going to the right is positive. And that's how it works, that you increase the positive, you understand, or increase the negative, and the radio works on that principle there. But you'll be controlling how much positive and everything with these settings here. But just to give you a good look, if you got your first helicopter, 60%, I'd say put your thing down at about 50% on everything on that. The dual rate, you could even turn that off, make that zeros. It don't matter. You won't want to be doing any mixing at this point or anything like that. Stay away from the mixes. But here it is right here. This is basically how you want to set up your helicopter. Of course, your channel 4, the rudder, might be different, where it can do the full travel path, so you don't need to cut off on the end points or anything. But here you'll program everything, and what you're looking for is the maximum range of movement. Let's go ahead and, but you see right there, as I tilt it, the aileron, oh yeah, I have to switch that, don't I? Where is my mouse? I have to reverse channel 6. Okay, now, you see as we go aileron left and right, that axis there does not move. It stays stationary or whatever. In the back, you can see it, I guess. That stays stationary, and everything tilts nicely around that center axis of that back post. Alright? I could go 100% on the elevator, because you'd want, when you push forward, this swash plate, you see that, to tilt radically forward. Now, if I switch it to auto mode, you know, it would react differently. Plus, I could adjust the pitch here, raise that, and now, of course, we're going to have different reactions and stuff, but you'd want that thing, everything, moving evenly at the full range of motion without the motors groaning after you give it full stick. There's no motor buzzing, no groaning. That burns out your motor, so be wary of that when you're setting up your helicopter. You want clean at the top, no sound. Ain't that beautiful? I talk so much that silence is great, but look, that's what you want. And then when everything's adjusted, I go all around again. I'm stressing the importance that ball doesn't move. You see that? Everything just revolves around that ball. When you can do that, you'll have a helicopter that responds precisely, because this swash plate is the key to the direction it's going to go. So if you have this perfectly leveled, it'll just lift straight up. And then if you have everything balanced, it'll hang in the balance. But if you have too much weight up front, of course it's got lower front. So you can use whatever you attach to, its cameras or whatever. You put it where it's balanced, and you'll check that when you're lift on the blades. Like right now, it's pretty balanced. You know, look at it. But you can easily adjust for balance by pushing tail up or tail down on your trims and sub-trims and stuff like that. But another easy way is you can move the battery backward or forward a bit, and you can find a place where it's balanced. But as long as everything's perfectly balanced and everything's level, perfectly straight up, swash plate level, it'll go straight up. And then when you tilt the stick, whoa, I've cut the power again. Sorry, one more little blackout there for you guys. You know, it's like New York didn't pay electricity this year. But anyways, these movements in the air, when an aircraft's in the air, it'll send it the direction you say, forward. That right there will start jetting forward, because if you have your throttle curve, you can give it 100% right then, and that thing will just flop on over straight like this and fly straight off on the blade. But there's, you know, there's pitch sliding perfectly in unison up, then forward, backward, side to side. Whichever way you put it here, that's the way it's going. So it's left, right, and it's going to move. This looks like minor adjustments on the swash and stuff like that. But in the air, that's enough to send something careening this way, that way, and every way. You're looking for clean sounds and everything like that. So I can't stress the importance that take your time, set your model up right, and as long as you have precise control, you'll be able to precisely control it and get it back and not crash it somewhere, because that thing's wanting to do what it wants to do. And you have to set up a helicopter with a peace of mind that it's all balanced and it's a rotary craft and everything like that. No, you have to balance that thing out. These blades, you'll have to make sure that these things are perfectly equal in weight, because if it's not, you're going to have little problems. And if everything's nice and smooth and done right, then it's going to fly perfectly right and respond perfect to your controls. This belt shouldn't be over tight, you know, that runs back there, but it should be snug, you know. The blade shouldn't be pitched, you know, if you have a helicopter with a fly bar, it shouldn't pitch more than 6 or 7 degrees in angle and stuff like that. If you have fly bar, let's go 10 and 11, but anything more than 6 to 7, because of the fly bar's mass already trying to spin, it's just going to slow your rotor hub down where you have low head RPMs, and you'll have a lot of problems burning out the tail, you know, the belts and things like that, because of that low head RPM. So you want to keep that thing pretty much 6 degrees. You know, you adjust for all that on linkages if you have to, but 6 degrees, as long as you keep it at that, you know, you've got enough RPM on the head and stuff like that. And basically, you just have to pay attention to detail. Make sure that everything, as I was trying to emphasize yesterday, I think, is like this perfect, precise, dead straight back on the level. But the main thing you're worried about is the swash plate, because as long as that's level and everything like that, the craft is going that direction. Say I'm going to adjust the trim now, that's what that is there, the trim thing, but say I'm going to, the thing's leveled like this when you're taking off, and that's your swash leveled. Alright, you can tell that the thing's going to go on that swash that way on the takeoff, because that's the way the swash is. The pitch it's riding in the back is going to push it that way. But anyways, thank God for you guys. The camera time's up on this piece of crap, and I hope you guys got a basic fundamental of what these things do here. I'll touch on it more later, right? And I'll see you guys later. This is Zach Gold.